All right, welcome to another video. So if you watch this channel, you're way ahead of the curve when it comes to knowing about AI. So my last series, I read Situational Awareness by Leopold Aschenbrenner. I use ChatGPT in every video on this channel. I talk to it as if it were a person. I know how to prompt it very well. My tips for prompting it are to have a conversation with it. If you don't like something about it, ask it to do something different. One of the things I don't like is it'll list off long and go on long tangents. So you can train it. You know, you basically have to teach it, and it might take several prompts to do that. So I'm a big I err on the side of prompting it too much rather than having one perfect prompt that does everything. And now what that means is I hit my cap. I hit my message cap quite a bit. So I'm in ChatGPT jail right now. I hit my message cap, and I was right in the middle of a study session. So let's get ahead on the let's get do some of the hands-on exercises in the meantime, because probably won't need it in the same way for that. So we can see I have my own images in my own lab set up. I was working on OSPF. So let's do that just in my own quirky way here and finish what we got. So what we got is a configuration on here. So we're going to need to complete out the configuration on the rest of the devices so that it matches the labels we have here. And so that our ultimate goal is to run some verification commands and have those commands look like what we want. So let's run the verification commands first and see what the results of that are, and then we will see later. And then we will work to get them to look better. So the first verification command that I will run as part of this is the command show show IP OSPF neighbors. It's a classic important command. Now you see the neighbor table. It keeps a table of all the neighbors it has. If a neighbor goes down, it removes it from the table, so we can see these other devices aren't configured, so it doesn't have a neighbor for them. It only has the neighbor that we configured in the last video. The next one I will do is show IP OSPF. So this looks fine. We can see the backbone and the area 5 on this. So this router here is configured great. It's got 3 active interfaces. So if we go on one of these other links and sniff them, even though the other side is not configured, we do see hello packets are sent out from the source of the IPv6 link local address that is tied to that router and .9, but we don't see any return, right? So we don't see multiple source addresses. We only see it from .9 and 0B for IPv6. So that's because of what we see in the output here. We've got 3 active interfaces, so it is sending out those hellos, even though there's not anything on the other side. We've also got shortest path calculations, shortest path first calculations. It's run 8 times so far in the backbone, as well as in area 5. Those are how OSPF picks a path. It does a Dijkstra's algorithm shortest path calculation based on the cost of the links, and then the cost of the links are based on there's a default based on the link speed, and now OSPF is a old protocol, so the default it assigns is often not granular enough, so you can adjust what that default is with a command to make it more granular. And then in addition, you can put in custom costs. But the more configuration you add, the less a dynamic routing protocol is dynamic. So Usually you just need that one command to kind of bring it up to speed, to be familiar about faster links, because when it was first developed, links were so slow back then. Now we've got 10 gig, 40 gig, 100 gig links, so it needs to be more granular to it needs to be able to account for the more granular, because it used to just assign the same cost for a link that was 10 gig or above, but in this era of 1 gig, 10 gig, 40 gig, 100 gig, you need to have a shortest path that favors those faster gigs that would otherwise just be considered the same value as the slower ones, because they couldn't imagine a connection that fast, or if they could, there was no need at the time to account for it. So let's go on to so that's the show OSPF command. So we're gonna see this one will probably not change that much when we get the other ones up. We'll probably see some changes in it that we'll see later. But for now, we don't see any. One thing I could do that would be really cool is to do this in VS Code, Visual Studio Code. That would be really cool. I can get fancy with this. I have another series where I do a bunch of automation stuff. So for now, I'm just going to keep it simple and work through this exercise. So okay, so let's see here. Then there's another one that we'll do. We'll do show IP OSPF interface brief, and I'll switch over to my nice keyboard, and it'll sound clackety on the camera too. So, all right, this keyboard's a lot better, and I don't even need to charge it anymore. It's all charged up. All right, so yeah, so now we've got show IP OSPF interface brief. Brief for output. We can see the state, which is important. This is just a loopback, so it's a different kind of interface. And now we can see the which one is the designated router, which one is the backup designated router, and we can see which ones are configured for point-to-point or point-to-multicast if that were the case. So the designated router basically acts as the point. If you have a point-to multicast or a point-to-point, you don't need a designated router, because the purpose of a designated router is to reduce the amount of traffic in that segment, so that it can operate, in a multicast or even unicast way, just by sending messages to that designated router rather than to every single router on the network. So it reduces the flood of traffic by quite a bit to have the designated router on a Ethernet broadcast or a non-broadcast multi-access, so non-Ethernet broadcast. If it's non-broadcast but it's still multi, like ATM or something other than Ethernet, you still need a BDR. Don't be fooled by NDMA, non-broadcast multi-access, because you still need it for the purposes of it being broadcast. The broadcast means non-Ethernet broadcast, but multi-access, it's similar to broadcast. It's just not, broadcast Ethernet. So it makes sense that it says that, because otherwise you could be confused about that. So that's what we see here. So the next command we'll be doing is and we'll see this command change quite a bit. We see that we've got one neighbor here. This is done, but here we're going to see this change, so that we'll have a neighbor for each of these. We might even see the DR change. We'll see, but I don't think we will, because I think it depends on which one comes up first. All right, so let's do show IP OSPF interface. All right, and now we've got each of the interfaces that are enabled. So this is the loopback interface, so it's its own special state. Here's the Ethernet 1.1. So now we've got information about the hello and the dead interval. So these are important concepts. There's also the wait interval and the retransmit. But the hello and the dead interval are the main ones, and I think they have to match in an adjacency. So hello is a keep alive. It sends it out. It's also used to establish new connections. And then a dead interval decrements, but is reset every time a hello is received. So clearly the dead interval has to be higher than the hello interval. It just depends how long you want a dead connection to stay alive. You have to, of course, not have false positives that it's down. So it has to be significantly higher. By default, it's 4 times higher. And if it doesn't receive a hello in that time, in the 40 seconds, then it will take the adjacency will go down, and it will be removed from that neighbor table that we saw before. All right, and now we have information about the designated router. Where is that? The backup designated router. We have the state of this one. This is the backup designated router. We have information about the local configuration. It's in process ID 21, about the IP address of the port that this is coming out of. So, and then we also have information about the authentication. We're using a keychain named MyPass, and we're using MD5 encryption. So that is that. So here's the other link here. So that is that again. So now this is for OSPF version 2. We're also going to set up OSPF version 3. So let's take a look at some of the verification commands we'll be doing for that next. So the first command we'll be doing to verify our configuration of OSPF version 3 is show, oops, and I need to reselect that. Show, oops, and something's not working now. It was just laggy. Okay, so it's show OSPF v3 neighbors. There we go. We got one neighbor happy there. That lag kind of concerned me, so what I'm going to do is close the visualization program. Yep, and we're going to quit without saving, and then we're going to stop the capture. I think if I have too many captures open, it might cause issues. So we'll close that one, and we don't need any captures open, so we'll close this other one as well. All right, so we're just going through which show commands I'll be doing. So I'll be doing that one, try to get better output for that. The other neighborships need to be up. Then the next one I'll do is show IPv6 OSPF v3 interface. And just like v4, everything is pretty much the same except for the IP address. We even still have a DR in v6. Everything is almost exactly the same, except now we have IPv6 addresses. Even the router ID is the same. It's IPv4 addresses, but it's not really an IPv4 address. It's just an identifier. But you know, everything is pretty much exactly the same. So moving on to the next command. All right, so I think that's it for the verification commands we'll be doing. Yep. So now what we need to do is complete this configuration, and then get some better results from this these verification commands. So let's get started on this one and make sure that everything is good to go. So show IP OSPF neighbor. Okay, looks good. PF brief. Oh. OSPF 3 neighbor. All right, so there we go. I'm pretty happy with that. So we've got these two commands, and these are up, so everything looks good regarding that. So now let's configure this adjacency. Okay, so here we'll go show run pipe section OSPF. So looks good to me. We've got everything there. If we do the same thing on here, we can see it looks quite a bit different. We got no output. So let's get working on that. Feature OSPF. Feature OSPF v3. All right, and then in the last video, I made it clear that you don't have to use the same process ID. You can or you cannot. It's just a local identifier. But I'm going to use the same one here. I've made my point. So I do recommend using the same one just because it makes it easier on everyone. But I've made my point, so we're going to do it here the way you'd be able to do it on any device besides a Cisco, which is really frustrating sometimes the way Cisco works. All right, this is a good way to do it. Now notice how I chose .1 for the router ID here. It's not going to come up, and I could demo that. So let's demo that. I don't want this video to be too long. I'm a little bit out of energy, to be honest. So we're going to start the capture. Now, if I filter out for OSPF, we should see those hello messages pop up. So there we go. We've got one here, and they're sourcing from .5 from that router in the middle there, and we're not seeing any others besides that. So that'll all change once I make this live here, and we'll see that in the capture. Okay, so you know what? I'm going to do this so that it's a mistake. I'm going to configure router ID 111, which is a duplicate with the other one, and we'll see that mismatch happen. So now we need, this is area 0 on this side. Authentication. So we'll get everything right except for that router ID and see what happens as a result. All right, so now we can do the interface. So I believe so. This is show run int 2. Yeah, it's the .5, and we saw that in the capture, so that's how we know this is the right interface. And then we can do show show IP interface brief. Okay, so there are no configured interfaces. So I'm not sure how to tell which interface is meant to be used here without going and looking at the diagram. It's important to have a good diagram so we can see very clearly it's interface 1. Looking at the diagram is fine. There's no shame in that. All right, so we need MTU 92.16. We need IP address 10.10.5/30. We need IP OSPF authentication. Message digest. And then let's yeah. So I misspelled that. But before we do that, let's look at the let's get that my pass keychain set up. All right. So keychain my pass key 0 key string, and the string is Cisco. Very secure. All right, so 1/2 is the one over there, and then here we're working with 1/1. So now we can configure authentication. All right, and we can make this a point-to-point connection because there's no other routers on this network. So you might have it plug into a switch where there's a bunch of other routers on there. If that's the case, then you can't configure it as point-to-point. But if they're directly connected, you might as well, because otherwise it'll go through that designated router process, and you can save a little bit of hassle with that. And not that you have to do that. Like it's all an automated process, but you can save some I think you might get be able to have faster convergence is what I mean. All right, so now we've got a no shutdown, copy run start, and we've got a so look, there's a problem here, duplicate source IP, and this is through ARP. So duplicate source address of packet received on 2 is duplicate of local 10.0.0.5. So we've got a number of problems here. The first problem is actually not with the router ID. I think when I configured the well, let's see here. So let's take a look at what I got on here. Yep, so see what I did? I configured the same address as I did on here. So we got a problem there. We should also have a problem. Oh, you know what? We don't have a problem when it comes to OSPF yet because it's not even sending it out. So what we have a problem with is ARP, and until we resolve that problem with ARP by not having duplicate IPs on this subnet, it won't send out hello messages from the other side. So that ARP, all of the underlying technology that it relies upon has to be set up correctly in order for OSPF to work. So let's fix ARP by correcting the mistake in the IP address here. All right, so now we got that. Be extra careful not to do a copy start run. You would undo all of your configuration and cause an outage. So we should see state go from loading to full. We should see a message like that, but it will happen at the end of a process that involves forming an adjacency. So we can see we're sending out the hello messages from both sides now, but the adjacency is not formed, and now we've got another error message here. So we've got another duplicate here. We've got a duplicate script, source IP, same thing. So I wonder if my changing, if I mistyped here. No, it looks like I didn't. So not sure what's that is all about. Yeah, so I don't have a duplicate. Okay, so I'm not sure what's going on there. That's interesting. You know what? Maybe this is what shows up when we have a duplicate router here. Yeah, because it says the source OSPF router here is .1, but it's the same here. So maybe it's the same sort of message that shows up if you have that. So let's try fixing that and see if that resolves the issue. All right, so things should look a lot better on the line now. There we go. This is what we want to see. And now we got a happy message rather than these error messages that are not so happy. We don't have it yet, but it should say that it's going from loading to full once all of this is complete. I'm going to do a sound check. There we go. So we're still not loading to full. Everything should be fixed now. There shouldn't be any mistakes. So I'm kind of surprised we're not getting the loading to full message yet. Yeah, we can see we've got the acknowledge from both sides. We also had link state updates. We had link state descriptions, link state requests. We had database descriptions, so that's all of the packets that were sent out. Let's take a look at some of these. So we looked at the header before. So now the header is fixed. We've got a source header of .1 there, and then .11 there. So now it can proceed. Let's look at the so this is the database description. Yeah, just some things like that. Okay, and now we've got actual link state advertisements coming out. Type 1 and Type 2, now that these database descriptions have been sent out, everything matches, because in order to form an adjacency, there has to be there has to be some things that match. They have to be both in the same kind of area, from what I understand. Yeah, so after that, we've got some actual link state advertisements. We got quite a few of them afterwards. We got a link state request to update that. Then we've got a link state update in response to that request. I noticed that the update comes from 5 and the request came from 6, because 6 was the new neighbor that didn't have the information about the area and all the links in it. So it requested it here, and then it received a request there, and we've got all of the information about what's there in there in a Type 1 LSA. But it's also an area border router. So we got a Type 2 LSA, and then it's also it also sent out the Type 2 LSA, and I'm tempted to say it's because it's the designated router, but it's I thought this was a point-to-point without a designated router. So I guess I'm a little bit confused by that. All right, so yeah, we've got more of that coming, more descriptions. Yeah, so looks good to me. Now, despite not getting that message, it probably is up. So let's do that show command again. So we're going to show IP OSPF neighbor. And yep, so so we've got it's in state is full. Show IP OSPF neighbor, and now we have 2 entries in the neighbor table. We can see we have a dash here for this neighbor because we made it point to point. All right, so let's take a look again at interface eth1/2, and we can see that looks good. Let's look at eth1/1. Looks good. So, and now let's look at the final one, eth1/3. So 1/3, we're going to have IPv6 as well as IPv4 configuration on there. So let's move to that. We'll do one more copy run start. It's important to do that, and it's important not to do copy start run, otherwise you will cause an outage. So there we go, copy run start. Yeah, only use copy start run when you're an expert, you verified it with someone else, and it actually does make sense. Okay. Yeah, so now we're doing -15. All right, and now we've got some configuration to do on this, and we'll sniff another link now so we can see what's going on here. And now notice there's another link state update and a link state acknowledgement there, so we can see we've got LSAs in the update packet. We've got LSAs in the acknowledge packet as well, and then from that we've got just hello packets that are preventing that dead timer from expiring. So that's all there is to see there. All right, so now let's take a look at what we got here. All right, so here we've got some chatter on the line. We've got CDP, so we could do a show CDP neighbors, which is pretty useful to do. Let's do that on this. So CDP neighbors. Okay, so we've got two CDP neighbors, but we're missing that third one. So let's work on setting that up. And we do have those hello packets coming out. Right now we're only interested in that, so let's filter it out for OSPF, and then let's complete the configuration. Okay, so we're going to need to first enable the feature. And might as well do both at a time since this one uses both. It's probably a typo. Typos happen a lot. Okay, then router OSPF 2.1 doesn't have to match, but we'll make it match. Router ID 1.101.15. Okay, looks good. And then this is the stub area, and I know that from the diagram and from the configuration on the ports. All right, so that's all we need. It's just going to be that one stub area. So now we're going to do area 23. We don't need to worry about area 21 because that's the other side. So we're going to do router OSPF v3 23. All right, area 0005 stub. All right, looks good to me. So next is the interface configuration. Okay, so we're going to need to put a unique ad. Let's try not to make that same mistake again. So interface 1.1 IP address 10.10/10 IPv6 address 201 db2:2/48, and then IP OSPF hello interval 25. So let's not do this, and let's see what happens if I don't change that. OSPF 21 area 0005. Okay, IPv6 router OSPF v3 23 area 05, no shutdown. So let's see what happens here. I have a feeling there will be problems. Okay, so we've got everything going here. Let's do a neighbors. So show IP OSPF neighbors. So see, we've only got two neighbors. The third neighbor didn't come up yet. And show OSPF v3 neighbors. If we do that command, yep. So the command, so it did come up here. Oh, you know what? It didn't come up here either. Okay, so that's interesting. All right, well, let's see if we can see where it failed. So this is for IPv6. We can see IPv4. It didn't even go through that process at all. And that's because in the packet we have the hello interval setting. So in these other ones for IPv4, and we can just filter that out. So we can do IPv4 like that. Oh, you don't have to specify v4. So yeah, now we're just going through, so we can go down through all the packets. And yeah, see that mismatch there? So we've got 25 and 10. so they can't form an adjacency together. So. All right, so now if we fix that error, everything will be fine. Okay, so we'll have a match to the other side. Run start, not start run, that would be a disaster. Okay. And we should see some good news on here. Now it's to 25, so it'll take a while. But there we've got a hello. So still nothing. But we've got those hellos coming out now. It's just 25. It's a lot of time. Okay, so we've got one coming from .10. We've got one coming from .9. So I think it's going to be about a minute because I think it has to receive more than one hello packet in a row. I'd like to check in with ChatGPT on that, but unfortunately, I'm going to try to keep this video a little bit short because I don't have access to ChatGPT. I can use version 3.5. I might even be able to use version 4 rather than version 4.0. Oh, you know what? It's saying that I have it available. All right. Well, you know what? Maybe there's an issue. So let's do a little bit of troubleshooting here. But as far as I know, it looks like you know what? The one thing I didn't set is the MTU. So it could be that the MTUs aren't matching. Yeah, so the MTU here is 1500, but there's no custom configuration on the other side as far as I saw, so it shouldn't make a difference. Yeah, MTU will match. I wonder if I just didn't know shut. Well, you know, the short port is up for sure because I am seeing those packets come out. So yeah, we've got a bit of an interesting issue here. Yeah, we got a CDP neighbor. Everything's looking good. So yeah, we're just not getting a. Oh, you know what? Okay, so yeah, that actually looks good. I'm not sure why that didn't why that kind of threw me for a loop there. Let's take a look at show these 6 OSPF neighbors. All right, so that's good. Yeah, I was thrown for a loop because I didn't see it turn black here for IPv4, and I still didn't see it turn black for IPv4. So I don't know why That didn't get sniffed, but it's up. It's in DR. So maybe I'm not sniffing the right link. It looks like I am. But okay, so it just didn't make it into the capture. That's okay. That might happen. All right, so let's do those verification commands that we did before one more time and see much better, prettier results. And then that will be the end of this video, and that'll be the end of the OSPF hands-on exercise. I might come back and retouch and go over some concepts, but soon I'll be moving on to BGP. All right, so if I hit the up arrow, spam it. This is the first one we started with, show IP OSPF summary address. And that was not, I think, the command I was intended to issue. Yeah, this is the command here, intending to issue. So, oh, what? What the heck? This might be a lab thing. So there's no neighbor here. But if we do the same command, show IP OSPF neighbors. Oh, okay. Well, I don't know what I was doing before. Okay, well, that's fine. Okay, no shutdown. Oh, see what the issue is? See, this is what can happen during networking. It can be this difficult. So I misconfigured it. You know, I'm just doing everything. This is not the way network engineers usually do it, just on the fly at their keyboard. They usually use templates or some sort of automation or something. So I hit 10 an extra time, and that prevented it from coming up. So now that I hit that 10, I can do a copy run start. And we're going to have better results after a while. I could sniff that, but let's just wait on the line. Now it is 25 seconds, so it'll be a bit longer. You know what? I think I am going to sniff. And it should be happening pretty quick here. Maybe there's another issue. Let's see what it looks like on this side. So see what the issue is? I changed it to /24. It was meant to be changed to /30. All right, so now we should see some of that happy black color in the sniffer, and we should get a message saying loading to full, and that would be a better outcome for sure. There it is. That's the good stuff. That's what we want to see. So, so now all I need to do is go through these commands again. So we're going to do this command. I think I entered that in accidentally. Now, yeah, we've got 3 of them. That looks a lot more happy. And then we've got the next one was show IP OSPF. Yep, there we go. So there might be some changes. You notice we have the administrative distance. That's an important CCNA concept. That means if multiple routing protocols are configured, which one will be used. It depends on the administrative distance. The one with the lowest administrative distance is used. So direct connections have an administrative distance of like 0 or 1. I don't remember, but we can see it if we do show route. Or show IP route. Yeah, so we can see the administrative distance I believe it is. So we should. Oh, you know what? We're not receiving any routes through OSPF because they're all directly connected. So the example is a little bit not so good. A better example would be to have a link here, because then this device would learn that through OSPF. So you know what? Let's go ahead and do that. We're going to set up a link here, and then we're going to see it learned over here. So let's do that. And then okay. So show run int /2. Okay, and then we'll use 1.1 as a template. So interface eth12 IP address. Let's go with 172.16.0.1/30. Okay, and then we'll do IP router OSPF 20 area 0000. All right, no shut. We'll only worry about okay. And now the other side. All right, and this, I think this will be a good lesson for why it makes sense to have the process numbers the same, because I don't think this will work because the I used a different oh, you know what? No, it should work. It should work. All right, so now we do have an OSPF route. See, so the administrative distance for a directly connected route is 0. I was right. and we can see for a OSPF route, it's 110, and then the metric is 80. So there we go. We got it. OSPF-21. Oh, is that the, yeah, so the process ID on this router was 21. You got it through there. And then we selected through via 10.10.2. So, all right. So I think that's probably everything. I think that's all of the verification commands. So we did neighbors. We did show IP OSPF. Let's do brief next. So there we go. Everything looking good. They're all in up now. So and then after brief, we've got show IP OSPF interface. We'll do that one. Okay. All right, now we'll look at information about v3 neighbors. So we've only got oh, you know what? We've only got two. Yeah, we've only got two v3 neighbors as expected. We don't have v3 on port 2. Okay, now show IP OSPF interface. There we go. Link local addresses. So FE80 is link local. All right, and then that's it. So we've got a much better output now. So that's going to be it for this video. Thanks for watching, and see you in the next one.